Hi guys, I hope you're all well and having a good day. Assalamu alaikum. I have yesterday posted 15 MCQ questions which were really handy for you guys, and you guys have liked my video and watched it. So it has inspired me, and now I'm making a video regarding the predicted January 2025 Physics Unit 4 question. I have predicted 2 or 3 questions along with some difficult multiple choice questions which you guys can go through today in order to score high on your exam tomorrow. Hopefully you guys will score really high tomorrow, and I'm really hopeful that your exam will be really good. We are just left with 2 or 3 hours before the exam. This video is the perfect video that you guys should go through, and I have tried to make this video as simple as possible. I have shown 2 maths. Please go through these 2 questions before your exam today. You guys can actually revise them in order to score really high, because these are the 2 questions that will come in your exam today. So best of luck guys. Fi amanillah. Sending tons of love and luck your ways. Have a good day guys. Alright, so let's now go through this question. The diagram represents an arrangement to demonstrate electron diffraction. Okay, a beam of electron is directed at the sample of a crystalline material. Which of the following single changes would decrease the angle of diffraction? So what we are going to do is we are going to decrease the angle of diffraction. We are here to decrease the angle of diffraction theta. We know when an electron is passed through this sample, it is diffracted. So what we will do is we will try to decrease this diffraction. We know in order to decrease this diffraction, according to the formula, lambda is equals to h by p. If we have to decrease the diffraction, we have to decrease the value of wavelength, and if in order to decrease the wavelength, we have to increase the momentum. Now we know kinetic energy is equals to p squared by 2m. So in order to increase the momentum, we have to increase the kinetic energy as well. Now according to the formula of kinetic energy is equals to charge into voltage. In order to increase the kinetic energy, we need to increase the voltage. Now we have to increase the voltage. Here they have written increase the anode potential. So we have to increase the potential of the anode. All the other points are not that important. We are not dealing about the distance, we are not dealing about the filament's current or whether the atom is spacing or not. This is not even included in our syllabus. So more or less all of them are not our answer. The only correct answer will be B. Now a sphere traveling at speed v collides elastically, so the kinetic energy will be conserved with an identical sphere which is at rest. After the collision, both spheres move at an angle of theta to the direction of travel of the first sphere. So this is an angle from this angle, which is the direction of the travel of this first sphere. The sphere have the same speed as each other. They have the same speed. Okay. So as the kinetic energy is conserved, we can calculate the speed of the spheres after the collision using the kinetic energy formula. Now what we will do here, the kinetic energy will be half mv squared plus 0, because this has no velocity, is equals to this half mv squared plus half mv squared, the kinetic energy of both the particles. Okay, now here if we take them right here, half mv squared plus, we are going to take this half m as common, half m. We can take this as u and this as v. This is v1 and this is v2. v1 plus v2 squared plus squared. Okay, now we can cancel out this half m and this half m, so we will be left with v square is equals to 2v squared, because both of them have the same speed. They have said both of them have the same speed, so we can take them as 2v squared. Now as we have taken v square is equals to 2v square, in the question they have asked what is the speed of the squares after the collision, of the spheres after the collision. So now we have to deal with this. We have to make this the subject. So what will happen is v square divided by 2 is equals to v square, and then this will become v is equals to root over v square divided by 2, which is equals to v divided by root over 2. So our correct answer is B. The diagram shows two metal plates with a potential difference V across them. There is plus V and this is 0. Okay, there is a potential difference. The path of an electron traveling within the plate is shown. So this is the path of the electron. Electron is deviated through an angle of theta. Which of the table shows the changes that will cause this theta value to decrease? So they are asking how the theta value can be decreased. How the theta value can be decreased. We know when an electron is passing through this electric field, an electric force is exerted onto it. That's why it is deflecting like this, right? An electric force is exerted. So let's write down the electric force formula, which is charge into electric field strength. We know electric field strength is equals to force per unit charge. So force is equals to charge into electric field strength. Now charge into, we know another electric field strength formula, which is V by D. Okay, as they're dealing with the V and distance part, we have bring that formula into the game right now. Now we know electric force is equals to mass into acceleration, or not electric force, actually force is equals to mass into acceleration. So because as they're deflecting, it is accelerating, right? The acceleration is happening. So as the acceleration is increasing, as the acceleration is increasing, that is why it is deflecting. So in order to decrease the theta value, we have to decrease the acceleration of the electron so that the theta value decreases, so that it deflects less. The more the acceleration, the greater the deflection, the greater the theta. The lesser the acceleration, the lesser the theta value, the lesser the deflection. So we have to decrease the acceleration. So in order to decrease the acceleration, we have to decrease the V and increase the D, because V is directly proportional, so it should have been decreased, and D is inversely proportional, so it should increase. So our V will be halved and the D will be doubled. So our correct answer will be C. If I make you guys understand again, we can see the magnetic field is like this. The magnetic field is like this, and the current is going right here. So we can take the current in the right direction. Then our force will definitely be into the page. So we can say our correct answer is A. You can use your Fleming's left hand rule in order to figure that out. Alright, so let's go through this question right now. A proton is accelerated by uniform electric field. Okay, the uniform electric field. We know the configuration of proton is 1 1. After time t, the speed of the proton has increased by del v. Okay, a helium nucleus, which is 4 by 2. Helium is 4 by 2. Okay, this is the configuration of proton, which is 1 1. It is 4 by 2. Is accelerated by the same electric field, so the electric field will be uniform. After what time will the helium nucleus achieve the same change in speed? So they are asking about the time. Now we can see one thing, that we know the formula of electric field strength to be force per unit charge, right? We know this is force per unit charge. The formula of force is mass into acceleration divided by charge, and we can also write it down as mass into del v by t divided by the charge. Now if we multiply this E with this charge, then it becomes EQ is equals to m into del V divided by the time. Now if we make T the subject, it becomes m into del V divided by EQ. Now we know during force on helium, it has 4 times more mass. So we can say 4m into del V divided by E into the charge, as it has 2 times more proton, so we can say it has 2 times more charge. So now removing all the constant, let's say del V and E is the constant, we can remove them. What we will found is 4 divided by 2 into this m into this del V divided by this E into this Q. Okay, this formula is exactly the similar formula to this one, which was for the proton. This formula is exactly the same, but the difference is just this 4 by 2. So we can say that this time will be 4 divided by 2 into this time. so the value will be 2 times. So we can write our answer as B. Our correct answer is B, which is 2T. Though it was a bit confusing, let me rectify the other parts again. Let me show you this part again. The T is equals to m into del V, but here the m will be 1 minute. Here this m will be 4m because it has 4 times greater mass than the proton, into this del V divided by E into this charge will be 2 times because it has 2 times more proton than this part. So now this 4m divided by 2, this 4 divided by 2 is written right here, and all the other parts have been written just like it was. Now what we have figured out is this value is exactly the same as this value, this value, but the difference is only this 4 by 2. So we have written 2 into this time, and this time is the value of the actual time that we are figuring out. So it is 2T. Done and dusted. Alright, so let's now go through the another magnetic field question. A wire is in the same plane as magnetic field of magnetic flux density B as shown. The wire is length L and carries a current I. Okay, which of the table gives magnitude and direction of the force on the wire? So this is the current which is at an angle, and according to the angle, this is our B. This dotted line has been given as our magnetic field, which is perpendicular to the current, So this B was like this, but right now it is at an angle, so this can be, it is within the angle, so we can say B cos phi. We know in order to find the force, we use B cos phi into I into L, right? We use B cos phi into I into L. Now here we have got BIL cos phi, but now we have to figure out whether it is into the page or it is out of the page. We know here that the current is acting in this direction and the magnetic field is acting right here. If the current is in this direction, we will put our second finger in this direction and our first finger in this direction. What we will figure out is our force is into the page. So our correct answer will be A. Now moving to another difficult question, we can see right here is when the potential difference across the capacitor is V, the energy stored by the capacitor is W. Which of the following gives the energy stored by the capacitor when the potential difference is 2V? So the potential difference has increased from V to V. Now we know they have asked us about the energy stored. We know energy is equals to half CV squared according to the formula. Half into C, as this value has become 2, we will multiply 2V squared. So what it will become is half into C into 4V squared. Now 4 into half CV squared. We have taken 4 as common. What we have gone is energy is equals to half CV squared is same, but there is 4 times multiplied. So we can say the energy has becomes 4 times to the previous half CV square value. So our correct answer will be D. Okay guys, so this is one question that is going to definitely going to come in your exam, is deriving the expression of A is equals to V square by R. This question comes as 5 marks question. This will definitely come, hopefully it will come in the January 2025 today's exam, physics unit 4. So I will recommend you guys to revise this question because this is a very repetitive question and more or less in every year it comes, but in the October 24 paper and maybe in May 24 paper it didn't come. So it will definitely come in the January 2025 paper, hopefully. So if you guys want me to make you guys understand this paper, we can see that we can say, let's say one car was traveling in this circle. So when the car was traveling at this position, it had a velocity, and when it traveled through this circle and it came right here, it had another velocity. The magnitude of the velocity was similar, but it has changed its direction, right? It has changed its direction. So let's denote it as V and let's denote it as VB. So what we have done is we have taken this VB. We have taken this VB and drawn it like here. This is our VB, and this VA has been totally horizontal, and we know between A and B the car has changed its direction. As we have taken VB as positive, what we will do is we will take VA as negative because the direction of the the direction of the car has changed. The direction of the car has changed. So we will take VA as negative. So as we have taken VB, now we will add the VA to the head of this VB. We will connect the head of the VB with the tail of the VA. So now we will draw it like this. Sorry, my bad. So this is now our VA, which is going to be negative. Our VA is going to be negative because the car has changed its direction when it comes from VA to VB. Now what we will do is we will draw a horizontal, we will draw a resultant vector. This is our resultant, which will be in the opposite direction. So now we have drawn the vector diagram. This is the vector diagram that you have to accurately draw during your exam. Okay, after drawing them, we have to derive acceleration is equals to V square by R. Achha, the thing is, the resultant vectors, this arrow will be like this. Let's say it is coming from it, because it was like this and it is like this. Let's say it is coming right here to here, but it will not go along this path. The resultant vector needs to be in opposite direction to the directions of these two. Okay, this is how you guys will write it. Another thing is, this is the perfect example of writing. Let's say it is coming from this and going like this, but here the del V is coming in the opposite direction to the direction of VB and VA. Okay, now we know angular velocity is equals to theta divided by time taken, and if we make theta the subject, theta is equals to angular velocity into time. Okay, if theta is equals to angular velocity into time, we also know that V is equals to radius into angular velocity. Now what we can do is we can write theta is equals to angular velocity divided by time from here, and we can put V is equals to RW. W is the subject, then V divided by R becomes. We can see right now here that theta is equals to angular velocity into time. So we can put this V by R into time right here. We know from this equation, from this vector diagram that we have written, if we take here sine theta, if we take here, this is the theta, if we take this as theta and this is 90 degree, then this is our oppo and this is our hypotenuse. So our oppo is del V divided by this velocity, and this VA is same. The velocity, the magnitude of velocity is same, so we can take it down as V. This is also V. So del V by V is equals to our sine theta if we have taken sine theta. Now when the sine theta value is really small, actually this value is really small. This theta value is really small. So when the theta value is so small, then sine theta can be regarded as this point you need to mention here. The sine theta is equals to theta. So when sine theta is equals to theta, we can say theta is equals to del V by V. This is the formula that we can take into consideration. Now we have figured out that del V by V is equals to theta. If del V by V is equals to theta, then we can write it down as this Vt by R is equals to this del V by V, because both of them are theta values, right? Theta is equals to this. So what we can do right now is we can convert this theta right here. Now what will become, and this V right here. So v into v divided by r is equals to del v by t. So we know del v by t means acceleration, and v into v by r means v square by r. So we have definitely derived this formula. So make sure you are adding all of these points to your exam paper to get a full 5 marks, which question will come in today's exam for sure. So my assumption for the January 2025 exam is, my prediction is that there will be a circular motion question which will be really important. So I'm not going to show you circular motion answers right now, just 1 or 2 hours before your exam. What I will do tonight is I will show you guys one very important cheat sheet that you guys can use in your exam day. The cheat sheet will be that no matter what the tension is like, the tension's vertical component, which is t cos theta, will always balance out the weight, and the horizontal component t sin theta will be the reason behind its centripetal force. So always write t cos theta is equals to weight and t sin theta is equals to mv square by r, just like this. And if it is required to figure out the value of the theta, then use sin theta, then divide sin theta by cos theta and make it as tan theta, which becomes v square by rg, because we cancel out the masses. This is how you should use the circular motion. This is the most important, most easiest way in order to use the circular motion. And please read this whole question that I have written for you guys right here, because it will be important for you guys, because you can revise that just before your exam or just 10 minutes before your exam. And if you find it difficult, if you find this question difficult, then it's not important for you to remember this or read this. Just make sure that you understand t cos theta is equals to weight and t sin theta is equals to mv square by r. If you find questions really difficult, then just answer it by this. Let's not look after any other things, or let's not try to figure out any other ways to solve the answer. Just write it down here. But yeah, don't write it blindly by memorizing. Just look at the question and try to answer it by yourself. If you can't, then do this formula, because it's better to at least answer than not answering. So make sure you are answering the circular motion question today. Now let's look at one more very important question for this question paper. What we have seen is this Lenz's law question. There is a very high probability, and my prediction is that there will be a 6 marks Lenz's law question, which will be there for you guys to answer today in your physics unit for exam. What they have written in this question is, a student uses a strong cylindrical magnet to investigate Lenz's law. The student recoils the time taken for the magnet to fall through 2 hollow tubes of copper A and B. The 2 tubes have the same length and cross-sectional area. They have the same length and cross-sectional area. Tube B have a vertical slit cut onto it. So there is a vertical slit right here. Discuss the differences, the time taken for the magnet to fall through each tube. So before understanding this part, the most difficult part in this question is regarding the vertical slit part and the time taken. So it is the question. So these are the 2 difficult parts, which holds only 2 marks. The other 4 marks is gettable by using normal common sense and memorization based answers. This question worth a 6 mark question. So first of all, what we will do is, as it is a copper hollow tube, the magnet will fall. So as the magnet is falling through a magnetic field, there will be a change in flux linkage as magnet falls through the tubes. This is our first mark. This will give us our first mark. So when there is a change in magnetic flux linkage and EMF is induced, we will write that an EMF is induced. And we all know, when an EMF is induced, that EMF drives a current through the tubes, as the tubes are made up of conducting materials. We have to mention that as the tubes are made up of conducting materials, the current will flow through them. You can also mention forming a complete circuit. Though this forming a complete circuit is not required for this question, but in more or less every Lenz's law question paper, it is required to write that which forms a complete circuit, because mentioning the complete circuit part gives you another mark. So make sure whether it is a circuit in your exam paper. If it is, then definitely write which forms a complete circuit. Okay, now the current that has been created by this magnetic flux linkage of the magnet falling, now this current produces another magnetic field. The current creates a magnetic field around the tubes. So now this magnetic field created by the current and the permanent magnetic field of the magnets will create a force. According to Lenz's law, there is a force opposing the motion of the magnet. We have always learned that creator opposes the creation. So when the magnet was falling right down the tube, the magnet created a magnetic field, right this. Now this magnetic field will interact with the magnetic field of the permanent magnet. So when this magnetic field will interact with the permanent magnet, the force will be in such that it will oppose the motion of its creation. So that means when the magnet was falling through this copper tube, this was the reason behind this magnetic field to be created, right? So it will always oppose the motion of its creator. So as the magnet is falling, its magnetic field is producing. So what it will do is it will try to stop the falling of the magnet, like it will try to stop the production of itself. So Lenz's law, there is a force opposing the motion of the magnet. Magnet takes less time to fall through tube B. It takes less time. Why it takes less time? Because the current that has been created through the induced EMF is small here, because the slit reduces the number of paths for current in the conductor. Because right here, as there is a slit, the current in this conductor is less. As the current is less, the EMF will the magnetic field produced, this produced magnetic field will be smaller as well. That's why it will be able to oppose less. It will be able to oppose less the motion of the magnet. That's why it will take lesser amount of time. But here the magnet falling from right here will experience more force opposing its motion, because the creation always opposes the creator. This motion of this magnetic field has created this motion of this magnet has created this magnetic field, and now this magnetic field will apply a force on the magnet in such that it will oppose the motion of the magnet falling. That means we can say in one thing that the creator is opposing the creation. I hope you guys have understood this part, though it is not that easy to understand this question straight away just 2 or 3 minutes before the 2 or 3 hours before the exam. But what I will say to you guys is, always try to answer some key points from this question. If you guys have no idea regarding this, you can still score 1 mark, 2 mark, 3 mark and 4 mark from this question. These 2 marks are difficult to achieve, but the other 4 marks are really easy to achieve. So make sure that you are writing them and memorizing these first 4 points before today's exam, if you haven't taken the preparation according to the way you should take.